Good morning, everybody. In this video, I'll talk about the three diode approximation. Let's start with the first approximation. In the first approximation, and we're going to talk about the forward bias of the diode. What is the forward bias? So when you have a diode, then this terminal is called the anode, and this terminal, which is represented by the bar, is called the cathode. When the anode is connected to the positive terminal and the cathode is connected to the negative terminal of the battery, we call that as a forward bias. And in the forward bias, the diode behaves as a closed switch. That means it does have a zero resistance. It behaves as a perfect conducting material. So what does this mean? That means even with the slight voltage, the current in the circuit will be very, very high. That's what it denotes here. That's the forward VF stands for the voltage in the forward bias, and the IF stands for the voltage in the current in the forward bias. And even with the zero voltage, or it means even the slight voltage, the current in the circuit will be very, very high. That's what it means. And in the reverse bias, means when the anode is connected to the negative terminal of the battery and the cathode is connected to the positive terminal of the battery. We call that as a reverse bias. When the diode is connected in the reverse bias, it behaves as an open switch. When I say the open switch, that means it does not allow any current to pass through. This means it behaves as a very, very high resistance. This also means it doesn't matter how much voltage you apply, there will be zero current in the circuit. So the first approximation is never used in the real life. This is a very, very ideal approximation and is never used in the real world. So you can see here, so in the reverse bias, the VR means the reverse bias voltage. So even the voltage we increasing, there is no current in the circuit. It does not matter how much voltage you apply, there will be no current in the circuit. So it's a very idealized approximation. So now let's talk about this second approximation. So in the second approximation and in the forward bias, now you might have understood what is the forward bias, so I'm not going to talk about the forward bias. In the second approximation, a diode can be approximated as a closed switch, plus there is a voltage drop across the diode. So what does this mean here? This means you need a certain amount of voltage to pass the current through the circuit. So this is called a bias voltage. The VV stands for the bias voltage, and this bias voltage means you need a certain amount of voltage so that there will be current in the circuit. Remember, in the first approximation, even without any voltage, or let's say very, very tiny voltage, the current was very, very high. But in the second approximation, what does it tell you? You need a certain amount of voltage that we call as a VB. And this VB we call as a bias voltage depends upon what kind of diode you have. For the silicon diode, here I have mentioned, for the silicon diode, the voltage is 0.7 volt. And for the germanium diode, for the germanium diode, it has to be 0.3 here. Let me correct here, 0.3 volt. And for the germanium diode, it has to be 0.3 volt. So what does this mean? When I apply 0.7 volt here, only in that case you will see the current through the circuit, or only if it is greater than or equal to 0.7 volt, the diode will turn on. Before that, if you apply 0.65 or below, or let's say below 0.7 volt, the diode will not turn on. That means there will be no current in the circuit. That's what it means here. Now if you look at this, the graph here, before the bias voltage there was no current in the circuit, and as soon as you apply or the voltage across the diode reaches the bias voltage, there is a huge current or the surge of current in the circuit. Okay, now in the reverse bias, again the diode even in the second approximation and in the reverse bias, the diode simply acts as an open switch. That means doesn't matter how much voltage you apply, the current in the circuit will be 0. So in the summary, for the second approximation, for the forward bias, the diode behaves as a closed switch plus the bias voltage combination, and in the reverse bias, it simply acts as an open switch. And this the bias voltage means you require this amount of voltage, 0.7 volt for silicon and 0.3 volt for the germanium, to turn on the diode. But now let's talk about the third approximation. In the third approximation, we use the diode as a closed switch plus the bias voltage plus a resistance RB. Okay, so this RB we call the bulk resistance. Let me write down here. RB stands for the bulk resistance. Bulk resistance, and VB is the bias voltage. So what is the bulk resistance means? That means this is the resistance of the diode itself. Anything that is made of material must have some resistance, and that resistance is the bulk resistance, or we can call as the resistance of diode itself. So in the third approximation, we have the diode can be approximated or can be viewed, can be viewed as a switch plus a closed switch plus as a voltage drop that we call the bias voltage plus the resistance. And this is the real picture of the diode. Any diode, if you look, behaves exactly as the third approximation. That means it does have a certain voltage drop plus it does have a resistance that we call the bulk resistance. And if we apply the voltage, or if it is connected across the battery, then the current in the circuit can be given by this equation. So what does this mean? Now let's say you apply 1 volt here. If you apply 1 volt and you know that for the silicon diode you need 0.7 volt to turn on the diode, that means 0.3 volt will be across this bulk resistance here. The total voltage must be equal to the supply voltage. Now if this is 5 volt, then this one again will be 0.7 volt, and across this resistance it will be 0.3 volt here, 4.3 volt here. Okay, so in the third approximation, a diode is approximated as a bias voltage plus resistance, and that's the equation for the voltage. Now let's talk about the reverse bias. In the reverse bias, the diode can be approximated as an open switch, but it does have some internal resistance that we call as a bulk resistance, and this bulk resistance is connected just like in parallel with the switch itself. So and here, just to make a better picture, I can connect this one to a battery here. So this one will, let me do a little better job here. So that is the positive terminal, and this one will be a negative terminal here. Oops. And then I can connect this to here. Okay, so why did I do this one here? So that means, now let's say if I supply a voltage, then there will be some current in the circuit. So in the second approximation, in the first approximation, the current was exactly equal to 0, but that's not the case in the third approximation. In the third approximation, there is some resistance of the diode, and the current can pass through it. All right, so here is the summary of this one. Again, the VB is 0.7 volt, and let me make one more correction here. For some reason I have written down 0.7. This has to be 0.3 volt for germanium. So what does this mean here? We need at least 0.7 volt to turn on the silicon diode, and 0.3 volt for the germanium, the diode. And if you look at this graph here, what does this graph tell you? If the battery voltage or the supply voltage is less than the bias voltage, there will be no current in the circuit. And if you increase above the bias voltage, the current starts increasing linearly. And when you go in the reverse bias, then there will be a small amount of current, and that current we call as a leakage current or the reverse leakage current. All right, and but in the first and second approximation, this current was zero, but in the real world, or when you take into account the resistance of the diode itself, there will be some amount of current passing through the circuit, and that current we call as a reverse current or the leakage current. So that is it for the diode approximation. If you have any questions, any confusion, please let me know, and do not forget to like, share and subscribe the channel. Thank you very much.